All right, my friends, we are back for part 3, Return of the Jedi. We have Phil Jones here from Sound United. How you doing, my friend?
Good. More video stuff. When are we going to have a conversation about some surround sound stuff? Maybe we can do that coming up in the near
Yeah, I
future.
mean, I guess it kind of leads to it because people want to know how they're going to get lossless surround sound through HDMI, through streaming apps, and HDMI 2.1. We've been talking about this now. This is the third iteration of this live stream that we're doing with you. And we're talking about what eARC does and how you can get that through the pipe from your receiver back to your from the TV back to your receiver. So today we're going to be talking more about the bandwidth and not using too much bandwidth when you don't necessarily need to do it. Yeah. And we're going to be talking about the cabling, thinking about future considerations for HDMI 2.1. Because let's face it, the standard is here. The hardware is still playing catch up. The software is still playing catch up. But we got to be ready for the future. We don't want to be snaking cables through your attic, 5-10 years down the road, because the cables you're using now don't have the bandwidth requirements for what's coming down the pipe.
Exactly. So Phil, that's what we're talking about. Just you're going to have to put something in the wall. You're going to have to prepare. So if you're going to do a cable that's 2 meters long, that's a pretty easy conversation. But many of you, like me, have a projector or a rack, like something like this, and a TV that's like 10 or 15 meters away. And we want to make sure that when we buy once, cry once. If I put that cable in the wall, I want to make sure that I can utilize it for a long period of time.
And then maybe you could talk about when we talk about regular HDMI cables, whether they should have Ethernet support or not, why that's important. Because you see cables that some have Ethernet, some don't. Maybe you could talk about that in the presentation.
Okay, and we could talk about that because the main thing is there's lots of strands of wire. Like if we go into the presentation, we can get into all of that as we go along
right now.
Okay,
let me get that going.
Yeah. So if you guys did not, we won't have a huge amount of time to get into the nitty gritty about bandwidth and additional HDMI 2.1 features. If you want that, we actually did 2 sessions over the last 2 weeks that we covered that stuff in detail. So for those who haven't met me yet, hi, I'm Phil Jones. I'm the Director of Training for Sound United, and you can see it's all of our brands: Denon, Marantz, Class A, Definitive, and Polk. And I've been doing this for about 20 years, so a little bit of video experience, a little bit of audio experience, and it's kind of nice to be able to put it all together. So
yeah, guys, and I'll link up parts 1 and 2 in the description below in the video in case you guys want to catch up and watch that and then come back to this. You're more than welcome to do that.
Exactly. And we also have some very extensive material on our Sound United training site, which Gina will put the link in the description, hopefully after, if you really want to dive into like a 1-hour conversation on just 2.1. Because we know we have, so we know we have this new standard, 2.1 specification. The funny thing is you'll never see 2.1 on the box. They can't put it on there. So we can say ultra high speed and other 8K, 4K, but you won't see 2.1, but that's the new spec. And that was because they wanted to give you better video, better audio, enhanced gaming, and a better user experience. The biggest challenge was the massive increase in bandwidth. So if you go to the next slide, we talked about before that there's 5 things that make up a video signal. You can also talk about maybe color subsampling, which we'll get into later. It's resolution. How many pixels are each frame? How many frames am I showing? How many numbers am I using to describe the color? Okay. And then, of course, there's other things like what's the brightness range? What from 0 to 100 nits, from 0 to 10,000 nits, and then also what color space, what color triangle am I going to use to describe the colors? So those are the 5 basic elements of video that we normally talk about. If you go to the next slide, these are the 2 that have been increased by HDMI 2.1. So we're going from 4K to 8K, and then we're going to up to 120 frames per second. So yes, you can end up with more data in the pipeline. So if you go to the next slide.
Now for frame rate with Ultra HD Blu-ray, it's still at 24 frames per second, right?
Yes, it's still at 24 frames per second. It's funny. Everybody, the big thing is 8K 60 and 4K 120. Movies are going to be shot in 24 for a very long time. most of you guys out there, I'm a vidiot. I like my cinematic movies. And whenever you get above 24p, you get kind of, people say it complains that it looks like it has the soap opera effect.
Yep.
A lot of times when they've shot movies at those higher frame rates, it doesn't have that cinematic feel. It feels more like action video. And so a lot of times studios, even though they have the capability of shooting at much higher frame rates, have stick to 24. It also allows them to hide things like when they pan, like a set being held up by a stick. So they like the advantages of 24p. So it's great to talk about it, but a lot of the movie content you see is still going to be in 24p.
Gotcha.
So cables, that's always been the big thing. So we're talking about this additional bandwidth. And if you have a shorter cable, it's a good chance that that cable will live a long life. But as the cables get longer, it gets more and more difficult to move the signal from point A to point B. Now, the cables are going to be used differently in HDMI in HDMI 2.1. It's the same type of cable. There's the same amount of strands inside the cable, but how that cable is used, those lanes in the cable are used to transfer data has been changed. And the goal was to increase for the increased capability of up to 48 gigabits per second. Up to doesn't mean they're going to use it. We'll talk about that in a second, but up to, which will give you at uncompressed 8K at 60 frames per second and 4K at 120 frames per second.
So right now we're at 18 gigabits a second.
We're at 18. We're at 18 gigabit because that is all that it was required to show you 4K 60p HDR material. As I increase the frame rate or I increase the file size, I mean the resolution from 4K to 8K, that each frame is 4 times bigger. I need more data. So that's why we have the higher bandwidth. So the old cables, basically there was 3 lanes that passed data, those TMS channels, 1, 2, 0, 1, 1, and 2. And then there was a clock channel that made sure that all 3 of those channels stayed in sync. Each one of those channels would passes, they used to call it 6G or 6 gigs. And you could measure it with something like this. And like all of us calibrators have these things, and you can measure it and you could see that it would say 6G. And because there's 3 lanes, or 3 channels, 3 times 6 is 18. So that's the way the cables would work. Now it's changed. And what they did was they took that, if you go to the next slide, they took that that channel right there, and now that channel is designed to pass data. It has to pass data. So if you advance it to the next slide, so now instead of 3 lanes, it is a 4-lane highway. And these 4 lanes, if they all pass 6 gigs per second, you get 24. If I increase it up to 12 gigs per channel, I get 48. So the hard challenge is now each lane, if I do 48 uncompressed, has to carry twice the data, twice the traffic that it used to have to carry in the past. So that is why it gets harder and harder to make cables longer and longer that can support these types of data rates. Okay. So the new term that you're going to hear now is FRL, basically lanes. Think of them as like lanes of traffic. And those are going to be measured a little bit differently using a measuring device like this one. This is the new Murideo 7G, the new test pattern generator. And there's some really cool things that this can do. The first thing this can do is it measures, if you have a 2.1 source, it'll tell you how many lanes that the TV's chipset can support, and what's the maximum bandwidth of each of those lanes. So my friend Vincent Teo at HDTV Test used this yesterday, a couple of days ago, and discovered some interesting things on a couple of HDMI 2.1 TVs. They don't pass as much data as you think that you think they would, but you don't really need that much. You can also do things like test eARC and all of the other stuff with this. And this is also going to have the ability to test up to 48. So this is going to be kind of the new test pattern generator. If you have a calibrator come in your house, he'll be carrying something like that.
So somebody on our chat is saying, stop running copper for video and data. Why aren't we all doing fiber at this point?
Yes, I am a big fan of fiber. I mean, this is 75 feet of fiber. You put this in the wall, you are good for a long time. But at the same time, copper still has some advantages, and depending on the length that you're using copper, you're still going to be okay for up to a certain distance, which we'll talk about a little later.
Gotcha. All right, let's get back to this slide.
Okay, the next thing is not only are they change the way the cable is used, and now you have 3 lanes. If you go to the next slide, they're adding a new set of compression. So if you go to the next slide, and this is actually called if you go to the next slide, DSC, display stream compression. So this allows them to, it's a lossless compression, which will allow them to push more signal down that pipe. So, and this, with using this compression, 2.1 is good for over 10K content at over 60 frames per second. So hopefully we won't be having this 2.1 conversation for another conversation about a new format for a while.
So it's kind of like, it's kind of similar to like with audio. When we started getting high res audio, we got MLP, Meridian Lossless Packet. Same kind of thing. It's lossless compression, right? Exactly.
So so by using, if you knew, like, it's almost, it's exactly, it's completely lossless. You're not going to notice the difference between the uncompressed and the compressed.
Cool.
So, okay, so move on. What this is this talks about, if you look at this chart, the amount of data or bandwidth that is required to pass a certain amount of signal. And then also to pass that signal, how much data has to go down each lane. And this kind of explains the whole thing. When Vincent actually tested a bunch of he's on HDTV Test. If you want to check him out, I got to give him a shout out. He actually tested a couple of TVs, and he discovered that I think it's an LG, the current LG he has, as well as a current Samsung 8K TV, can only support 10 gigabits per lane of the 4 lanes, which means 40 gigabits per second. So it's an 8K TV. Or 4K TV, it can do 4K 120, but the maximum that TV can take in is 40, not 48. And by the way, that chipset is going to be utilized and there's only basically 2 chipsets that everybody's using for the displays, and neither one of them do more than 40. So the set you're buying are probably going to tap out at about 40 gigabits per second.
Gotcha. Wow.
So we're talking 48.
We're never going to see the max capability, at least anytime in the near future.
Yes, I mean, we're talking 40, we're talking 48, but you're only going to see 40. Now, before you get upset, the panels that are available today for consumer TVs, whether it's an LCD panel or an OLED panel, are a 10-bit panel. So if you look at this chart, 4K at 120 frames per second, with 444 color sampling at 10 bits is 40.
Yeah.
So that is the maximum that panel could support. So having any more would be like me telling Gene to drive his Honda 400 miles an hour. He knows what I want it to do, but it can only go as fast as it can go. So having that is good on paper. It's great marketing, but it may not give you a real world advantage on a TV you're going to be buying for a while.
Gotcha. So 10 bits is our current technology on display devices.
On display devices. And there's only like 3 or 4 panel manufacturers out there. That's from my other gig that I used to do. And because of that, 10-bit is the thing. So, and 10-bit is more than enough. You're not going to see any gradations in the sky. You're not going to see any banding if it's done properly. So 10-bit is great. 12-bit sounds good, but 10-bit is great. That leads us to the next thing. Bigger is not always better. I see gaming guys, and I see people who go into their Oppos and their gaming systems and their Apple TVs and crank everything up. And this is it sounds good on paper to have the big number, but it doesn't mean you're going to get you're going to get an advantage. All you're doing is making it harder to pass the bandwidth down the system that you already have or the new system that you're planning on buying. So by turning it up, you get no benefit, but everything has to be more robust to support the fact that you like the big settings on your on your media player or on your computer. Okay.
So the end result of doing such a thing could be audio or video dropouts or just malfunctioning, right?
Or no picture.
No
Because
picture at
a
all.
lot of times, one thing that's interesting about HDMI is if you exceed the bandwidth of the chipset, no picture. That's it. You know, now normally it will not allow you. The EDIT of the TV will or the display device will tell the particular device, I can't go that high. Don't send it to me. But if you go into an Oppo, I can force an Oppo Blu-ray player to do whatever I want it to do. So if I go in and I just crank everything up, you may end up with a blank picture. I've had it happen when I had a Sony projector and a Sony TV, and I was running a splitter. The Sony TV identified itself at 18. It tried to send 18 to the projector, which could only handle 10, and I ended up with no picture. So don't get carried away. So if you look here under the, for example, I just picked the regular stuff that's available right now, 4K content at 24 to 30. And if you look at it, you could use 18, 444, 12-bit, and get 18, but most of the content on the disc is 420, 10-bit. So basically 9 is more than enough. You just cranked it up because the number looked cool, you know, not because it was going to do anything for you, because you're going to see 444. But are you going to let the Blu-ray player or the media player do it? Or are you going to let the $4,000 or $8,000 TV do it? So if there's no reason to crank it up, if you don't have to.
Right.
Okay. So use the bandwidth wisely. So keep going. So for example, we just talked about that. 24p, 4K HDR content with BT 2020 at 420 is less than 8 bits, 8 gigabits per second. So 18 sounds really good on paper for HDR marketing, but most of the time, if you don't get carried away with your settings, 8, 9, 10 is more than enough for you to get a spectacular picture out of an OLED or LCD TV.
And that's including the audio track on top of that as well?
Well, it's funny. This is only the video tracks. Remember, the only thing that goes down those lanes are video. There is a second, a different lane for the audio and the other features. It's funny. I was talking to Matt Murray, the nice guys that keep supplying me with all of these cables and test pattern generators, and they say they're one of their biggest challenges right now at AV Pro Store that makes Murideo and everything else in AV Pro Edge equipment is now there's even all of the other things they're adding. Such as eARC and other things that are actually now putting a bigger load on those peripheral, those secondary wires, and those are becoming harder and harder to pass data at longer distances.
Okay.
So, and then of course we just talked about this. If it's only 10-bit 420 on the disk, you cranking it up is just going to put a load on the projector or on the system that is just unnecessary. It's not like the projector is going to still show it to you because it's going to do the chroma sampling and the internally. So why turn it up from 444 to 422? Now
on the back of the disc, are they labeled that you know if it's 420 or 444? I mean, usually you don't get that information, do you?
All the spec that's on the disc is 10-bit 420. Period.
Okay.
That's what it's encoded in. Okay, that's it. You know.
Gotcha. That makes it easy.
Yeah, exactly. So continue on. Now, if you have some professional thing or you're a gamer, and you could take and you have triple massive mega game cards, yeah, you could produce a native 12-bit 444 signal using that particular thing. But the disk is 10-bit 420. Okay. I always say cranking it up is like buying my wife a diamond ring and sticking it in a shipping container. It doesn't make the ring any shinier. It doesn't make it any nicer. It just makes it harder to move from point A to point B. Okay. So keep that on. And like I said, there's a couple of things you do need to be concerned with. And some numbers matter more when it talks about what you can visually see on a new panel than others. For example, 8-bit 444 is bigger than 10-bit 422. If I did that on 4K, but 8-bit is only is nowhere near as many colors, 16 million versus over 1 billion colors. So even though the file size is smaller, the picture quality is better. So So keep that in mind. There's certain things you do. 10-bit is where you want to be at least. 10-bit is good. You know, you want at least 10-bit. If you get that and 420, you should be rolling for most displays. All right. Yep. So continuing on. So the first thing is, so now we're going to have to verify. I always tell people before you buy a cable, please verify the cable's capabilities. So there's lots of ways to go. If you're an installer or a good installer, will probably have a test an analyzer or generator in their particular lineup to test that. Okay, so keep advance. So one thing that we're going to do, that we're looking at doing is, if you go to the next one more, is when the TV will be able to tell you what features are available in 2.1. Here's another thing. Most of the displays are only going to use 40 of the 48. Now, the next thing is not every feature has to be supported on a 2.1 TV. So some TVs will support eARC and some TVs will not. For example, Samsung has not announced support for eARC, but they have announced support for variable refresh rate. So the nice thing about having the this in the receiver is when you turn the receiver on, it will show you under features what is available to go down that pipeline from that display. This device will do it as well, but I don't think you have. But this is $7,000, and it's a professional tool. It's kind of nice to have that built into the AVR, so you know what features are available from the source and from the display that AVR is connected to.
So this would come up, and when you initially set up the receiver, this kind of information would come up.
We have an info menu. So if you hit the info menu, it'll come. You can read it whenever you want, look at it, whenever you want to. So it'll show. So this is something that we put in there, so people can kind of just help people realize that it's an HDR. Because I remember when HDR came out, some TVs, my Sony, wouldn't indicate that it switched to HDR. I had to go through 3 menus to see that it was an HDR. So it is kind of nice to know. So how are you going to know that it is eARC? How are you going to know that QMS is on or variable refresh rate is on from the TV? So it's nice because the receiver is in between. It can, and it's a repeater. It can look at the information being passed back and forth between the source and the sync, which is the TV, and as a repeater tell you what they're communicating. So this is kind of nice.
Yeah.
Okay. The next thing, balance. Most HDMI balance, I use these all the time for long distances. That's what we're here talking about. Transferring lots of data for long distances. And a lot of people use these HDMI extenders, HD base T extenders. And many of them, they do a good job. First, they wouldn't do HDR. They weren't fast enough. And now there's systems out there that can support 18. Oh, by the way, they use lossless compression. It's 18 coming in. It's compressed, sent down the HD base T wire, and then uncompressed on the other side. So when I plug the test pattern generator in it, I see I've sent 18, and at the end I see 18. But what's going down that Cat 5 or Cat 6 is normally 10. It's just been up converted, or it's using lossless compression to move it from point A to point B. So they solved the HDR problem. The thing is, many of them did not, they didn't think about all the other lanes that they have to support. So things like ARC are normally not supported on most of the balance. I'm not saying that no balun will. These guys always hook me up with stuff to play with. I used to run around Cedia asking questions. Show me a HD base T balun that supports 18 gigabits in, 18 gigabits out. I don't care what goes on in the middle, and supports ARC. So they showed me this guy here, which is it's available on from AV Pro Edge or the AV Pro Store. So there are baluns that support ARC or eARC. You need to ask. The questions you need to ask is, what's the maximum bandwidth supported, and can it support ARC? And those are 2 things that if you do that, your balance can last for a long time. You may have to spend a little bit more, but buy once, cry once. You spend a little bit more, you don't have to worry about it. The reason why I'm talking about this, because everybody blames my receiver, my big black box, for the fact that their video is not working. And most of the time, it's all the little things you use to connect my black box to that big screen that affects your performance. Okay.
And the advantage of a device like this is if you're setting up an area in a big home where all your source devices are in a media rack somewhere, now you have a way of distributing that audio and video long distance throughout the house by not having to do HDMI. You do it over Cat 5 or Cat 6.
Yes. Cat 5 is far less expensive than a long piece of HDMI. So if I have a rack and a TV hanging on a wall, and that is like 20 meters, like 10 meters away, by the time you run it in the ceiling all the way over and then down to the TV, you could easily get to 20 meters that way. The other way is many of the receivers have second and third zone video. So maybe like in my house, I have another HDR TV hanging over my fireplace in my living room, and I want to send that signal there. And when I had the house built, I had coax put in the wall and 2 Cat 5s. So now I can actually send that signal from my rack all the way to my living room, so I can actually watch HDR from my Opal Blu-ray player on that TV that's all the way on the other side of the house. Yep, so there's some advantages to it. You just have to make sure you get good ones. ARC is going to be necessary, whereas ARC or eARC, because most of the time, the only sources that are going to be available are going to be game systems. So you're going to probably plug that game system directly into the TV, because you're not going to want to walk all the way all the way downstairs into the attic to play. If I want to play a video game in my living room, I'm not going to put the game system up here. It's going to be next to the TV. But what's going to have to happen is I'm going to have to send the audio from that game, it gets sent to the TV and sent back to the receiver using the same HDMI cable that would be used to send 4K regular sources to the TV. You have to use it. If you use optical cables on most TVs, the output from an optical cable on most TVs is only going to be in stereo or Dolby Pro Logic. ARC would at least give you multi-channel surround. It may be lossy, but you'll get Atmos and DTS:X. eARC will give you uncompressed DTS:X and Atmos. So make sure, like all the Denon and Marantz receivers have support ARC, and we've supported for over eARC, and those pieces have been to be able to support it for the last 2-3 years. Our flagship piece, that piece that came out about 2.5 years ago, supports eARC, and every receiver I can think of since the last 10 years can support at least ARC. So ARC is important.
And the only caveat is if you do toss link from a TV to a receiver, you can get multi-channel lossy surround if you turn the internal speakers off on the TV. That's what I've found.
Certain TVs. Certain TVs. And but a lot of times, it all depends on the streaming service, certain TVs where the speakers are playing, everything else. If you just use HDMI ARC, find the HDMI input on the back of the TV that says ARC, and most of the time, if you look at the back of your receiver, it'll say monitor 1 parentheses ARC. You plug that in, ta-da, surrounds, you'll get it. Oh, by the way, in the TV, people are asking me after the last 2 sessions, you got to go in and turn on ARC in the TV and enable ARC on the AVR, okay, to let them know. Now, some TVs will not let you separate CEC to control from the ARC. So if I turn the ARC on, CEC, which is it's called Consumer Electronics Control, so will also be enabled. But most new TVs over the last 2 or 3 years, and pretty much any Denon and Marantz receiver over the last 3 or 4 years, allow you to separate ARC from CEC. So you can have a custom integrated, you can have a custom system with a Harmony or URC remote control and still take advantage of the higher quality multi-channel audio. Gotcha. Oh, so somebody was asking, is there a latency with the compression? Yes, there's a little bit of latency with the compression when you use any kind of compression, but most of the time, it's minor. So when I'm using HD base T balance or some sort of compression based balance system, it's not enough to make it sound like Kung Fu Theater. You'll be okay. Okay. Oh, and by the way, the only other sources that are going to be coming are going to be YouTube and services that are built in YouTube, or maybe a Sony internal service or Samsung sponsored service. So you still need to use ARC because there's no announced players. There's none.
I haven't seen any YouTube broadcasting in multi-channel surround. Have you? It's always,
Nope.
I think it's always 2-channel.
Exactly. So YouTube, I'm not. They haven't. I mean, you never know. They may do it. The funny thing is, most of the 8K content on YouTube, you can't get out, even if you have an 8K TV. The media player and it's knocked down to 4K, and then it's upscaled by the TV back to 8K. So it's 8K content knocked down to 4, upscaled back to 8. So even if you're looking at 8K content off of YouTube on an 8K TV, it's still just 4K content upscale.
Interesting.
All right. So we always talk about verifying bandwidth. If you continue on, there's lots of tools to do it, because as the longer the length of the cable, the harder it is to pass bandwidth. So we always suggest always test your balance, always test your cables before you install, because it's better before you. Even if I had a rack sitting here, and I was going to install it myself, or I was an installer, I used to always take every single cable and test them all while they were right after I took them out of the box, and then I connected everything. Because if we have one bad cable on some of these systems, the whole system goes down. Do you really want to spend your afternoon trying to figure out what cable's the bad cable when you could have done it before? So always test. Okay, so there's ways to do it, and we'll talk about that. Now the cables are coming. Belkin has a 1 meter and a 3 meter copper HDMI ultra high speed HDMI cable that will pass 48 gigabits per second, and it supports eARC. That's great. But when you get past 2 meters or 6 feet, that's when it becomes a challenge. So there are some things that are going to be coming down the pipeline. If you go to the next one. Next slide.
Quick question. When you're running a projector to your theater system, you don't need a cable that supports eARC at that point, because you're not sending audio from the projector.
Exactly. So for example, that's a great point, Gene. If I had a balun that worked great for HDR, and I had a projector and I bought a brand new TV, I would take that balun and I would use it on the projector, because I don't need eARC on the projector or ARC on the projector. So long as it passed all the data for video, I'm good. Then I would buy a new balun that supports ARC, eARC for my display.
Gotcha.
So it all depends on if there's an internal source. I just did a demo. I just did a projector review on a little LG Cinebeam that had full 4K HDR Dolby Atmos enabled apps in it. And it had eARC on it. So you're going to start to see smart projectors that actually have services built in.
Yeah, those are the near field projectors. I think the Epson does that as well.
Yes, so you're starting to see services built into projectors. But right now, the big high-end ones, like my VW695 being plugged into my AV8805, I'm not really too concerned with ARC, because the projector doesn't have any. It's a big light beam. It doesn't do all that other stuff, you know. Okay, and like I said, there are cables that are coming. I showed you guys this cable last time. This is a bullet train, 10K 5 meter. Other companies are going to be coming out with these types of cables. This is not copper, because by the time you start getting into copper, it's going to get harder and harder and harder. This cable is basically pre-terminated fiber, is what this is. So instead of you buying raw fiber and terminating it, or buying fiber and using the little boxes to convert it, this is already pre-terminated. So this cable is good for 20 meters, 60 feet, or more than 66 feet actually. So there are cables that are coming. You'll see a lot more fiber optic or active optical cables for the longer distances, because they are the most reliable for passing high quality video for super long distances.
But they don't support eARC though.
This does support eARC.
Oh, it says supports ARC, but it doesn't say eARC.
I'm sorry, it supports eARC. This guy supports this guy supports eARC. So the nice thing is, look at the box. They will label the stuff on the boxes. So you'll start seeing that. I was talking to some guys from AV Pro Store and AV Pro Edge, as well as companies like Audio Quest and stuff. They're going to start labeling the boxes, because they can't put 2.1 on the box, but they can put ARC and eARC and everything else on the box to say that it actually supports it. Okay, so look for the labels. Fiber's the way to go. That's this stuff here. That is a blow up of this stuff right here. This is the raw stuff. So say you don't know if you're going to use it yet and you're building a new house, run a line of this to every room in your house, because this is good for 100. There'll be flying cars before we get past the need to do 100 gigabits per second. So if you can run fiber, even if it's fiber, just do it, even if you don't utilize it at this particular time. Okay, so let's keep going. And of course, the other option would be, this is pre-terminated fiber with the little tips on it, and then you will use like the balance, like think of this as the replacement for the HD base T. So this stuff, these can do it as well. So this is basically the same concept. You use these types of little guys. You plug that wire into the back of this little guy here, and you're good to go. And this supports ARC and everything else, and all of the other features that are available. So there are solutions that are coming. I would tell you to go to like avprostore.com or metra.com or some of these other, or also at Lona, some of the better companies, and look at the options that they have. But the things you want to be concerned with is, does it support ARC? Does it support eARC? Does it support 18? And does it support at least 40? Okay, 48 is great, but at least 40, and you'll be okay.
Okay.
And of course, these are some examples of 18 gigabit cables that are copper or active cables that were originally rated at 18. Now, these have 4 channels, so they're only using 3 of them currently to pass the video signals for 2.0B. The second you activate the 4th channel, there's a good chance that is at least a 24 gigabit cable. Now, if I had to chart again, that would be enough to support 4K 120 10-bit at 422 or 420, you know, instead of 444. So you still could probably use this cable for most of that high frame rate or 8K content. You just can't have that 444 label on the display. But like I said, you really don't need it, because the TV is going to do it for you anyway.
You know, it's good to finally see AudioQuest apply a DC voltage for a purpose on their cables.
I like these guys. I like this cable. I have one of these active. I have an active AudioQuest HDMI going from my projector to my TV, and it has been spectacular. Normally, I used to have problems with cables getting blanking. You know, like every once in a while, you lose that 5 volts and the picture would blank. I use this cable with a Metra. It's almost like a hot plug. It makes sure that my 5 volts at my display is always 5 volts. And I have yet to have a problem. This cable has never blanked out and would blank on me. In the last year and a half, I've had it. So it's a great cable.
Wouldn't you get a more stable 5 volts out of the second option, where it's 5-volt USB power supply, since it's its own power supply instead of relying on the 5 volts from the TV, or does it not matter?
Never utilize the 5 volts from the TV because it's designed to do that, but that 5 volts has a habit of drifting. And that used to happen to me all the time when I had another cable, and it would just fade down and the picture would go blank. So there's a couple things you can do. Like this cable here comes with this little guy. If you want to zoom in or switch, this is basically a little amplifier. So instead of okay, if you can't, don't worry about it. If you just go full screen, if you go full screen, so I could plug that long 20-meter cable into my TV, into my test, and it passes the signal perfectly. But for perfect reliability, this is like a little amplifier. It basically goes at the end that plugs into your display, and you get a cell phone adapter. You ain't got to go now. It gets a cell phone adapter, and it always ensures that 5 volts is 5 volts. You can get these at companies like Metra. Metra makes one that does that ensures that it's always 5 volts to ensure reliability.
But the AudioQuest one doesn't give you that option. It's the 5 volts off the display, right?
Yeah. So you just use this guy. Or if you look at the Metra cable, you'll see that it's physically connected to the cable. It's just part of the cable. I kind of like those. By the way, you can plug that into the TV's USB input, but then that fades and you still lose your signal. So if you're going to use it, use a cell phone adapter to drive it.
Gotcha.
Okay. And of course, these are optical solutions where you can actually, with different solutions when it comes to fiber links. And these were rated at 18, but I'm sure most of these can far exceed 18 and still also support ARC. Optical has no problems passing as much data as you want to throw at it. Okay, so so I would tell you, so there's a lot of solutions there. Many of you will not have the problems we're talking about because most of you guys maybe have a TV right above your rack. So we're talking lengths of 8, 9, maybe 12 feet. It's when you start getting into the above, I say above 18 feet on an HDMI cable is when you start having problems with 18, let alone 40 or 48.
Right.
Okay. So we go to and like I said, if you can't install that optical or active HDMI cable, if you go to the next slide, this is the little Metro, they call it a Gigabit Accelerator. This actually turns a cable into active and maintains a steady 5 volts of voltage. So this is another little trick for those people who've already ran a nice expensive AudioQuest or Kimber cable in the wall and they want to continue to utilize it. And this can speed up your cable.
This will work for if the cable's 5 or 10 years old and it doesn't pass 18 gig. This will allow you to do that.
Yeah, we tell people because a lot of times this is not inexpensive. This is a couple $100.
Yeah.
But it's still cheaper than if you had having an installer come back and pull that cord out. So like we talked about, Gene has a rope in his ceiling and say it needs to be a little faster to get to 4K 120 for his display. This may be a way of speeding it up just enough to get over the threshold to display the frame rates he's looking for.
And you only put it on one side, right, of the cable?
It's on the display. It's on the display side.
Yeah. Yeah. Okay.
Oh, by the way, that if a cable says has a label that says source or display, make sure you plug the source into the source and the display into the display. There's a little amplifier normally in those types of cables, and they are directional. If you don't plug them in the right way, they're not actively powered, and they will not give you the distance and the quality you're looking for.
It's one of those rare situations where cable directionality matters.
Yeah. One of the guys brought up, how come we just don't use 12G HD or SDI cables like the professionals? Because there's no copyright. The whole reason why HDMI exists is because of the copyright capabilities of HDCP. And there's lots of stuff professionals use to pass massive amounts of data, but it's not copyright protected. And the studio is not going to let you use it because they're worried you're going to take that movie and it will be video Napster all over again. So, and last but not least, these are some of the different test pattern generators that are available from the market. These can be anywhere from $2,500 or all the way up to thousands and thousands of dollars. If you advance, the last one, the big king of generators right now is this guy here. You'll see every reviewer that's doing like high-end projectors and high-end TVs are starting to utilize these. And because this projector can read the channels, we will know really quickly which TVs support 40, can support 40, and which ones can support 48, because all you got to do is plug the cable, HDMI cable from this box to the TV and read the edits, and it will tell you what it can do compressed and what it can do uncompressed when it comes to HDMI 2.1 per lane. So that is actually, so you'll start seeing, so believe me, by the end of the year, you will know, or the next 3 or 4 months, reviewers are going to be plugging TVs in to find out what the heck is going on. Okay. And then finally, for you guys, all of our receivers have HDMI diagnostics. We talked about this. I'm going to give Gene the information and you can talk to him about getting it, because this is like giving a monkey a shotgun if you're not careful with it. So we only want to people who are really comfortable with this type of stuff that's really technical. This is what you can use to measure your cables. So this is what I did before I put my system, and I didn't have all this fancy stuff that's on this table right now when I put my system in, and I use the HDMI diagnostics tool in my AV8805 to check every cable and every balun before I connected my 6-foot tall, 7-foot tall rack to make sure that I wouldn't have any problems. And this is built into our receivers. And as we go into 8K, we will also make sure that that is built into our receivers as well.
Nice.
Okay.
Yeah, we'll throw up some tips like this on our Patreon channel, guys. Give me a couple of days and I'll get that up there.
Okay. Okay. And I think that's it. I think that's the only thing we were talking. Oh, and then last but not least, worst comes to worst, always pull a piece of conduit. That you want to make your system future proof. A trip to Home Depot will make your system future proof. And it's a lot easier to pull a wire out through this than it is to call the installer back. So they can put conduit in. This makes your life easier.
Yeah,
all right?
Before drywall, obviously. This is stuff you do before drywall.
Mm-hmm. So those are the kind of things we wanted to talk about. We could spend hours talking about this type of stuff. We have, like I said, I'm going to do a far more extensive one on settings inside receivers and how to read data from a receiver for our Sound United training channels for those geeks who really want to geek out on that type of stuff, and as well as some other things on new surround sound formats and stuff like that.
Yeah, definitely. We'd like to have you back on, Phil. There's so many other topics other than HDMI that, you and I always talk about at trade shows and stuff that I think the audience would find interesting. Mm-hmm. So there's a lot of questions in here. I think we should volunteer Phil to come back at his leisure and respond to some of these. So
yeah.
Phil, I'm putting you on the spot, man, because I'm getting a lot of stuff. It's all product related. It's all about the Denon 4200 or, the Marantz products, if it supports HDMI 2.0 or if it supports eARC. So maybe you could come in and just answer some product related questions.
Okay. Well, yeah, what I can do is I could probably bring Brendan. He's our head of engineering. And if that guy knows everything. So I can cool. So I'll be happy to do that. Also, if you ever want to talk more about the madness of cables, I was talking to Matt Murray from the guys that build the test pattern generators, Murideo, and he has said, hey, whenever you want to get there, and if you want to, when things calm down, if you want to, plug a bunch of cables into these machines and see what it can do, they're more than willing to do that with you, because the better the people understand how to test and verify cables, the more reliable their systems are going to be.
Yeah, that'd be awesome to have one place where we have all this test results for these cables, so people know how far and what bandwidths these cables can support.
Exactly.
Without all the marketing jargon.
Yeah. So you're going to hear a lot of people haven't admitted it yet, but a lot of TV manufacturers are going to start mentioning 40 instead of 48. Don't panic. That's enough to get everything out of that display. So,
gotcha.
so LG, everybody was freaking out over the internet yesterday about the 40, but they're just the first one to actually let you know that that's how it works, and they're just being actually pretty honest about the whole thing, and that's good, because they're just being truthful. They're telling you exactly how it is, and I think I actually kind of commend them for that.
Awesome. Well, guys, I hope you liked this video. Phil, I really appreciate you doing 3 presentations for us and making these slides. It really adds to the illustration of what we're talking about. It's a very complex topic, and we're ahead of the curve because this is stuff that we're talking about that's not even being implemented fully yet, and it's going to be something that's going to impact the industry in the next couple of years or so. So guys, if you like this video, please thumb it up. Make sure you subscribe. I'll put the Sound United links down below so you can get more information if you want to see more about this HDMI stuff. Don't forget about our Patreon channel at patreon.com/audioholics. And until next time, my friends, keep listening.
Take care, everyone.